Solve this radical equation, where x is a real number. A usual way to solve a radical equation like this, is to remove the radicals by raising the equation to the power of 6. If we solve the equation this way, the resulting equation is a polynomial equation, with a degree of 9. Solving a polynomial equation, with a degree of 9, might not be easy. We will use the substitution method to solve this equation. Let t equal the cube root of x squared plus 4. Then cube both sides, we have t cubed equals x squared plus 4. So x squared equals t cubed minus 4. X equals plus or minus root of t cubed minus 4. From the original equation, we know that x cubed minus 4 must be greater than or equal to 0. So x must be greater than 1. The negative value of x is discarded. Therefore, x equals root of t cubed minus 4. Now substitute t equals the cube root of x squared plus 4, in the original equation. We have t equals root of x cubed minus 4. From 1 and 2, we know that x and t are given by the same function f of each other. We let f of x equals root of x cubed minus 4. Then the derivative of f of x, with respect to x, equals a half times 3x squared over root of x cubed minus 4, which is greater than 0, as x is greater than 1. This implies that f of x is strictly increasing. Thus t equals x. Now substitute t equals x in 1. We have x equals root of x cubed minus 4. Square both sides of the equation, and rearrange the equation. We have x cubed minus x squared minus 4 equals 0. We use the factorization method to solve this cubic equation. Negative x squared can be written as negative 2x squared plus x squared. So we can now write x cubed minus 2x squared plus x squared minus 4 equals 0. X cubed minus 2x squared can be written as x squared times x minus 2. And x squared minus 4 equals x minus 2 times x plus 2. Now the two terms on the left side of the equation have a common factor, x minus 2. So they can be written as x minus 2 times x squared plus x plus 2. The equation becomes the product of two terms equals 0. So either x minus 2 equals 0, or x squared plus x plus 2 equals 0. Case 1, x minus 2 equals 0. So x equals 2. When x equals 2, the left side of the equation equals the cube root of 2 squared plus 4, which is 2. The right side of the equation equals root of 2 cubed minus 4, which is 2. So x equals 2 is a solution of the equation. Case 2, x squared plus x plus 2 equals 0. The discriminant of the quadratic equation equals b squared minus 4ac, where a equals 1, b equals 1, and c equals 2. So equal 1 squared minus 4 times 1 times 2, which is less than 0. This implies that the quadratic equation has no real solutions. Thus, case 2 is discarded. So x equals 2 is the only real solution.